Yeah, and maybe it's perfect. Now I have some question about the function of the coupling. Could you please demonstrate?
Yeah.
Is this the right one?
Yeah, that's the right one.
Yeah.
So this is coupling for truck fueling. We have the connection part. We have a locking device here that when we make the connection, that we lock it first before we open it. Mm-hmm. So the function between connection and opening is separated.
Yeah.
And that was the point that we are able to make an automated version out of this later on. Mm. And this later on has already happened.
Yeah, so. But first you connect it to the vehicle.
Yeah.
And you make a proper connection, and then you maneuver the coupling again.
Yeah, we unlock it here. Yeah. We turn it back, and then we come into a purge position.
Yeah. Why purging?
The purge position means that we take out the air which is locked between the male and the female parts of the receptacle and the nozzle.
Yeah. And with the older design, you need to purge the complete line, the hose and the coupling and everything.
Yes, there were open systems without integrated valves, and this is what we finally did. We integrate valves, which are only opening when we make the connection.
Yeah, and now you are only purging the distance between the hose and tank unit.
Takes much less time, yes.
Good, but still, I see there is some locking device and turning and so on. It's, it's safe, I understand, safer, but still, you need to have a trained operator.
Yeah, you cannot do it in a wrong way, but it's sensitive for, let's say, misuse. If somebody wants to destroy it, it's more easy to do that when he has the possibility to operate more things. He has to do it manually. So if you don't understand how the coupling works and he's impatient, he can destroy a lot on the coupling.
Yeah, and the next one with a lot of electric wiring and pipes.
Yeah,
right.
That's the solution to make it even more safe.
Okay.
Yeah.
I don't know what's upside down on this one.
Looks more or less quite similar. So the front part is the same. You also make the connection, but instead of that you are operating the locking functions and so on manually, you only make the connection, and then you have automated function for locking, for the purging, for the complete fueling process.
Yeah, and all this is controlled by the dispenser.
That is all controlled on the dispenser side, yes.
So this one could be handled by the truck driver in the future.
Yeah, that's the idea.
Fantastic. The next question here is, how did we cope with extremely low temperatures? In the past, we looked at ceiling. The ceiling itself needs to stand the cold temperature or the media, the aggressivity of the media. But here, I believe it's even more challenging.
Yeah, the temperature are even lower. So we need to seal at minus 250 degree. So it's on one side challenge for the material, and to avoid that we only rely on the material in contact with the liquid. We place a second backup seal a little bit more far away from the liquid, and this is not as cold as the main seal. Oh. So then you can use sealings in rubber, which has much better performance when it's warm.
Yeah, but it's more or less impossible to have a material that by itself will withstand this. You have a combination of two seals.
Yeah, that's the idea.
The last one, what is required for you to be able to start production of the couplings for hydrogen? What in a large scale? For us, we have the solution, but the market and the production is not there yet. Could you say something about that?
Yeah, the industry is looking now for verifying the solution itself. we need only demonstrate that it's working in that way, and then we can scale up when the demand is growing. Yes.
Yeah. Simply waiting for the market.
Yeah.
At this stage. Okay.
Yeah.
Have there been any tests of the coupling? I could imagine that.
Yeah, sure. The couplings are used in applications where you need to have certification. So there are third parties involved, and they require that your testing and also the customer don't want to bring a new development into application without testing. So we were going from tests first with liquid nitrogen, what we can do here by ourselves, to demonstrate that it's working, the concept is working at low temperatures. And then you have to go further steps, test it with liquid nitrogen at test laboratories. And later on, then you will go into the field tests, and that's the stage where we are right now.
So here we are able to test down to minus 196 degrees.
Yeah.
First stage, and then
we need to go down to minus 253, and we need to show that hydrogen, which is much more much thinner than nitrogen, that the sealing concept will work also with thinner media.
And all this is done?
All this is done, yes.
Thank you. Okay, I believe this was most of the questions today, and thank you, Gerhard, for answering them all.
Yeah, thank you as well.
Yeah. If you have any further questions, you are free to contact us. Send us an email or simply use LinkedIn. Thank you very much for listening.
Thank you.